Hi Dr. Hamdan. Today our group going to present our project presentation which is production of ethylene with 6,000 ton per year from natural gas feed as our raw material. So we are from group 8 NYAI group. So me myself Yuvaraj, son of Kunalan 196320 and my three other groupmates which is Nurin, Afrina, Izzati, Binti, Mohamed, Rozaieed, Nuraina, Nabila, Binti, Ahmad, Ruzi and Mohamed, Irfan bin Khairil, Anuar. So next. Okay, so this is what we will discuss in our presentation. First will be the recycle stream. Second will be the design of distillation column, which is from unit operation. Third will be the aspect comparison, followed by costing analysis and health and safety analysis. So, for the Excel progress, the main goal of our company is to generate 99.99% purity of ethylene via oxidating coupling methane reaction. For the overall process, the natural gas was fed to the OCM reactor, followed by the amine absorber and regenerator, demethanizer, C2 splitter, and lastly will be the condenser. The main part of our progress in this Excel calculation was the recycle stream in this semester. Vapor outlet from the demethanizer will enter the mixer before they are recycled back to the OCM reactor. There will be a purging stream to make sure the accumulation term can be nullified by flow out additional stream. The purpose of a recycle stream is to make sure the unreacted reactant are reused, then ensuring the highest process efficiency possible. Purging streams are necessary to ensure there is a little to no accumulation in the system from the recycled stream feeding back into the fresh feed, preventing dilution of reactant due to waste chemical. So this will be our full PFD, which is first the compressor followed by ASU, heater, OCM, and the OCM is our reactor. So this is the first inlet for our reactor, and then the second inlet for our reactor is from the compressor, heater, and reactor, followed by the pressure reductor, cooler, amine absorber, and regenerator. And then we'll enter dryer to make sure no water coming out before entering the demethanizer. So we have two demethanizer, and then lastly will be the C2 splitter. The vapor outlet from the demethanizer will enter the mixer before it is recycled back. So when during the recycle, there will be a purging part here before it recycle, which is 50%. So this is the main reaction that occur in the reactor. So this is the first reaction, second reaction, and third reaction. Our production conversion is 6,000 ton per year. So next, I will talk about the recycle stream. So the vapor outlet from the demethanizer will enter a mixer and to the reactor. There will be a purging as I explained just now. So this is the BFD that I showed here. For the recycle stream calculation, from the recycle stream calculation, we use solver to get the solution. The initial flow rate column is the raw material that was fed, which is the natural gas. The recycle stream flow rate column is a stream from the mixer after the purging of 50%. The final flow rate is the sum of the initial flow rate and recycle stream flow rate value. Solver is actually a numerical iteration method where it is used to get the value of the root. I will explain you later. So this is the box of the solver. So the initial flow rate is the one I put earlier, which is the natural gas inlet. This is the recycle stream, which is from the demethanizer, and this is the final flow rate. Final flow rate is equals to the initial plus with the recycle. So this is the assumption that I made, the assumption column that I made. So different is the difference between assumption and the final flow rate. So I will set to the solver, which is I will set this value is equal to 0 by changing the cell of the assumption flow rate cells. So when I must make sure the assumption flow rate is equal to the final flow rate, so that the difference will be 0. So when it gets 0, so it is true. So this is the recycle flow rate that will enter the reactor. So we can see the comparison after recycle and before recycle stream. So before recycle stream, it is 2450.48 kilogram per hour, the outlet from the reactor. And after recycle, I can increase the production, which is 3626 kilogram per hour. Plus, I can increase the inlet for the methane. As we know, OCM reactor mainly the process is for conversion of methane. So we can increase the conversion of methane here. So this is the recycle stream, are the costing before recycle and after recycle. So we can see there is a negative value in our company, and after recycle we can increase it to make positive value. So that's all from me. Thank you very much.
My name is Nuraina Nabila Binti Ahmad Ruzi. My meter number is 199141. Okay, I will talk about the distillation column design. So our distillation column design have been did in the unit operation. So this design is to understand the further knowledge about the designing distillation column. Okay, in this design the column height, column diameter, size of holes, and so on will be identified. Okay, first we need to determine the requirement. Okay, in this picture we have determined the reflux ratio, relative volatility, and the Q line. Hence the number of plates that we gain is 30 and the feed plate is 14. Moreover, if we increase the reflux ratio, it will decrease the number of plates. Okay, next, the second step is to select the type of contacting device. In this design, we have select the sieve tray because it is economical and it is suitable for the liquid to gas flow in the low rate ratio. And our design is low rate ratio. And the type of material of the sieve tray is mild steel, and it is more affordable than the bubble tray or the valve tray. Okay, next, this is our specification that we have been calculated, and all this calculation is satisfactory in the in performance. Okay, so the reflux ratio that I have told just now is 4.5, and the theoretical plates is 30. And this design of the distillation column, we have include the 30 plates, and in between of the plates will be 0.4 meter. And moreover, of the our column diameter is 2.5 meter, which is we was set up to based on the flooding consideration. Okay, in this design, our percent flooding is 40.1, which is below than 85%, which is it is accepted. And then after that, our overall plate efficiency in this design is 54.47%, and the plate dimension that we have set is 0.3 meter, and the plate thickness is 5 millimeter, and our wear length is 1.9 meter, which is 0.76 of the column diameter. In the design, it should be between 0.6 to 0.85 because it will affect the percent flooding, which will be increased. Okay, next, our number of hole is 19,000, and the hole pitch is 0.0125, which is 2.5 times of the diameter of the size of hole, and the plate pressure drop is 86.5 mm liquid, which is below 100 fm liquid, which is the 100 has been assumed, and the plate pressure drop is also to calculate the bottom pressure. And as a result, the values that had been used in all this specification is satisfied and accepted. And for the calculation, it can be checked in the appendix in our report.
Assalamualaikum. My name is Nurin, Afrina, Izzati, Binti, Mohamed, Rozaieed. My metric number is 198456. Now I'm going to continue with Aspen Plus comparison and process improvements. So Aspen Plus simulation has been conducted for each units in our proposed plan. So in later slides, I'm going to explain comparison between the data obtained from Excel calculation and also Aspen Plus simulation. So as you can see here, the plan includes the separation of atmospheric air, ethylene synthesis via oxidative coupling of methane, carbon dioxide and water removal, and lastly, the purification of our ethylene product. So here is the main flow sheet from our Aspen Plus simulation. The first unit simulated in Aspen is compressor 1. Here ambient air is compressed from 1.01 bar to 11.9 bar. So when performing the Excel calculation, we assume that the temperature of the stream remains constant throughout the unit. However, as you can see here, the results from the simulation shows that not only the pressure of the stream increases, but the temperature of the stream also increases throughout the unit. So based on our proposed plan, outlet stream of compressor 1 will send directly to the ASU. However, in this simulation, we added a cooler in between the two units. So the purpose of the cooler is to bring down the temperature of the stream in order to meet the inlet requirement of the ASU. So next, the A stream enters the ASU. So this unit operates at 11.9 bar and 25 degrees Celsius. So from the table, we can see that data from both the Excel calculation and simulation shows that all streams coming in and out of the ASU is at the same pressure and temperature. So next, natural gas is fed to compressor 4, where its pressure is raised from 1.01 bar to 11.9 bar. Again, when performing the calculation in Excel, we assume that the temperature of the stream remains constant throughout the unit. However, same as before, the temperature increased when we compress the natural gas. Then outlet of compressor 4 enters heater 5 at a pressure of 11.9 bar. So from the table, you can see that the pressure of the stream remains constant when entering and leaving the unit. Only temperature of the stream is increased. So natural gas undergoes combustion in the OCM reactor to produce gas mixture. Here it reacts with the oxygen that was produced previously in the ASU. So both in the Excel calculation and the simulation, the operating condition of the reactor was set at 11.9 bar and 600 degrees Celsius. So next, pressure relief valve was used to reduce the pressure of the stream coming from the reactor. Same as before, when performing the calculation, we assume that the temperature of the stream remains constant when the stream is passed through the valve. However, based on the data from simulation, there is still a slight drop in temperature of the stream when the pressure was reduced from 11.9 bar to 5 bar. Next, hydrocarbon mixture enters cooler 8, where its temperature was reduced from a temperature of 600 degrees Celsius to 200 degrees Celsius. Both in Excel calculation and the simulation, only the temperature of the stream decreases. The pressure of the streams still remains at 5 bar. So next, the next unit is an amine absorber. Here, the process of removal of carbon dioxide was performed. So, both in the calculation in Excel and also the simulation, all the streams coming in and out of the unit is at the same pressure and temperature, which is 5 bar and 200 degrees Celsius. So next, the product stream enters the dryer. Here, water was removed. So based on journals, we assume that the outlet stream coming out from the dryer will be at a lower temperature, which is 20 degrees Celsius. However, from the simulation, all the temperatures of the inlet and outlet streams are at the same temperature. So another improvement made in the plant is that we added a cooler in between the dryer and our distillation columns. This is done to make sure that the inlet stream coming into the first distillation column is in liquid phase. So the last stage in our process is the purification of our ethylene product. So we start off with the first distillation column. So here we remove most of our nitrogen and methane. So here is the comparison between the calculation in Excel and also simulation. Next is the separation between the ethylene and also our ethane. So this is the comparison between the data from Excel calculation and also Aspen plus simulation.
Okay, next, I will talk about the economic analysis of our project. Okay, in this slide, we will talk about the raw materials. Our raw material is natural gas, water, monoethanol amine, and magnesium oxide. And the total of this average cost of the raw materials is 22.3 million. Okay, next is the operational cost. The operational cost is include all the equipment, which is we use the 0.337 of tariff electric rate cent per kilowatt hour, and the total of our operational cost is 9.4 million. Okay, this is the summary of our revenue. Our revenue, our product is just ethylene, and the price of the USD per ton, we include the minimum and maximum price, and we multiply by the by our product, which is 6,000 ton per year, and our revenue is the 33.9 million for the minimum price, and the maximum price is 34.6 million. Okay, as a summary, this slide is share about the profit. If the fixed cost of the fixed cost in minimum price in the minimum, we will gain the profit. But if the fixed cost is about in a high price, which is the natural gas will be high, we will gain loss. But in average per year that I include this, we will gain the profit, which is 2.5 million. Okay, as a conclusion, the profit will be gained if the price of natural gas is lower or at the normal price, and it will gain loss if the price of natural gas is high. Generally, the profit will be gained every year and the loss will be covered, because it is determined by the average profit.
Now let's move to health and safety analysis. There are basically 3 steps in disaster prevention. The first one is distinguish the key procedure and components of the creation procedure and how operational procedures remain carefully mixed in ordinary conditions. The second one is understand how critical failure points are identified and what measures are used to ensure safe operations. The third one is recognize the emergency reaction system that is installed in the working system. For inspection and maintenance, when protection structures are closed down, backup structures had to offer such substitute protection in advance for the main protection structure. Then the next one, right measures needed to be taken to prevent equipment from facing over pressurization, which is very dangerous for the plant. Then the pressure vessels need to be inspected gradually due to continuous operation and capability to corrode. Then we move to health analysis. For ethylene, it can cause headache, dizziness, fatigue, lightheadedness, frostbite. For natural gas, it can cause nausea, memory problems, loss of coordination, death. It can also cause death by suffocation. For methane, because it is displacing oxygen in the air, it can cause mood changes, vision problems, and facial flushing. For CO2, it can cause restlessness, breath difficulty, sweating, increased heart rate, elevated blood pressure, and also coma. And for nitrogen, someone can face difficulty to breathe and limit their visibility. For material safety hazards, for ethylene is very flammable and it will cause asphyxia. For natural gas, it is a very flammable gas. It may explode when heated, so it is required for any equipment that has natural gas in it, operating with natural gas, to keep away from any heat sources. For methane, it can cause serious fire hazard, produce toxic gases when involved in fire, and methane flammable massive explosion if it is ignited. For hydrogen, it can cause thermal burns, explosive when mixed with air, and oxygen, as we all know, it is the main source for any fire. And for equipment safety hazard, for the reactor which we use in our plant is OCM. The OCM can cause burns, explosions, it can release toxic gases and they cause toxic effects, and can also cause electric shocks. For heater, as the name said, it is very at high temperature and can cause burns and also can cause shock. For compressor, it is very dangerous for any operator, so it may even cause injuries. And for distillation column, it may release dangerous vapors because the main components that operated in distillation column are mainly gases, many vapors, and all dangerous substances. In conclusions, our company has achieved 99.9% purity of ethylene, which we use in our plant. We use oxidative coupling of methane. Then it is proven that recycle stream can help increase the conversion of reactant and produces higher production of yield. Then we actually increase our profit and reduce our wastage. For recommendations, it can be recommended that the waste products and impurities should be treated accordingly to reduce wastage and to also to increase our profit. Then we need to consider the cost of air, although it is maybe sometimes it is free or negligible. And we should also consider the cost of water, although it is very cheap, and also the cost of each equipment. Including all this costing, we can really know how is our company do, to see if we profit from the plan or not. That's all from our group. Thank you very much.